moments and center of mass. Example 1. This uniform rod is balanced on a support, and the support has to be placed right at the center for the rod to balance. It's as though all of the mass of the rod was concentrated at a single point here. This is called the center of mass, and the weight of the rod acts at the center of the mass. Now we have a non-uniform rod. Again, if the rod is placed on a support, if the support is placed at the center, intuition tells you that will not balance the rod. We need to move the support to somewhere around here to balance the rod. So this time, if we again assume all of the mass is concentrated at the center of mass, which is here, then the center of mass is not in the middle, and all of the weight of our rod can be thought of as being concentrated at the center of mass at this point. So that's where you draw the weight force for a non-uniform rod. It's not in the center. Example 2. So we have a non-uniform rod of weight 20 newtons. So the center of mass will not be in the middle of AB. So X is the distance from A to the center of mass. Two supports are placed under the rod as such. So there is a normal reaction force at the support D and C. The normal reaction at C is 3 times the normal reaction at D. So that's given. Find X. Resolving forces vertically, taking the upwards direction as positive. So 3r plus r minus 20 equals 0 because of equilibrium. So r is equal to 5 newtons. Taking moments about point A and taking the clockwise direction as positive. So we have 20 times x, the perpendicular distance from point A, and this force is downwards. That creates a clockwise direction around A, so that's positive. The 3r force is pointing upwards, so an upwards force about point A is anti-clockwise, so it's minus 3r times 1, so minus 3r. Force r is a distance 2.5 meters from A, and the upwards force here again produces an anti-clockwise rotation about A, so it's negative. So force times the perpendicular distance there, so minus 2.5 r. The whole system is in equilibrium, so the resultant moment is equal to 0. We already know the value of r, so we can work out the value of x, which is 1.375 meters. Which is a sensible value because we can see from the diagram it should be a little more than 1 meter. For practice, try these questions.